All right, logs. This is not a full lesson, so relax. If you feel we need a full lesson, we will do a full lesson on logs. So this is kind of like an overview of logs. Before we get started, guys, logs and exponential functions are inverses of each other. So the same rules that apply to exponents apply to logarithms, just a little differently, but it's the same. Chav, I have no idea what you're talking about. So side note, I'll put a side note somewhere. So if you have x squared times x cubed, whenever you multiply something that has the same base, what do you do to the exponents? You add them. So this is x to the fifth, and that 5 came from 2 plus 3. So it's the same thing with logs. Whenever we have a product in the argument of a logarithm, you can expand it by adding them. And don't worry, we're going to talk a little bit. All right, so it says, all right, guys, let's start with the basics. Any positive number can be written as the power of 10. This is true. So I have 3 can be the same as 10 to the power 0.4771. 5 is 10 to the power 0.6989. 15 is 10 to the power 1.1760. And those 3 little dots mean that it keeps going forever. And if you're wondering, well, where did we get those numbers? 0.477, 0.698, 1.176. Well, that's the base 10 logarithms of 3, 5, and 15. Chop, I have no idea what you're talking about. So if you push log 3, so log is next to the number 7, log 3, and you push enter, you get this number, you see? And if I store that number, so let me see, I'm gonna store it perfectly to A like this. If I store that number and I go 10 to the power of that, so look, 10 to the power of this number that I just got, so I stored it as A. Look, it's a perfect 3. See? If I were to, I think, let me see, let me try it. It might say 3, it might say 2.99 or 3.000001 because I'm cutting it off. Okay, it says 3, so no big deal. So there it is, guys. So how do we get that 0.4771? Well, look, log of 3. So what are we showing right here? Log of 3 is 0.4771. Log of 5 is 0.6989. Log of 15 is 1.760. And then I put, so Chavez, where do the properties of logs come from? Well, we kind of referenced that. So let's see. 15 is 3 times 5. Do you agree that 3 times 5 is 15? And then let's see. What do we say that log 3, that if I were to put log here in the front, log of this, whatever you do to one side, you do to the other, right? Log of all that. So then that means I can write this as, let me see, what do I want to do first? I'll write it as this. Log of 3. Yeah, I guess I'll start it already. Hold on, guys. I'm trying to think of what I want to do first. Okay, I want to do this first. I want to do, what do I want to do first? Okay, let's skip this to step 2 because I want you guys to really see it. So you see how right now 3 is equal to that? So this is like saying 10 to the power 0.4771. And then 5 is like saying this. So that's like saying 10 to the power 0.6989. And of course, dot, 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 it keeps going, right? And you see how I have the same basis? So I can say that's the same thing as 10 to the power 0.4771 plus 0.6989. Oops, power there. And that should work. It should. Let's see if that works. So I'm going to have, let's see, that's at 0.477. I'm going to go ahead and put all these into letters already. Log of 5, I'm going to store that into B. Store alpha B. All right, so check it out. So I'm going to have 10 to the power of A times 10 to the power of B. I didn't put power there. Power alpha B. Okay, when I push enter, this better say 15. Oh, MG. Can I also do this? Look at this. 10 to the power, and I'm going to put A plus B. And that also better be 15. See, isn't that cool? So, Chav, what are you trying to get to? Well, okay, see, look, here's the second step of what we're talking about. So if I were to put a log here in this and a log here on that, whatever you do to one side, you do to the other. So it's already here, guys. So it's already written there. So see, I put a log and log. So this is the same thing as saying log 3 plus log 5. And I know you're probably looking like, Chop, where's the connection? I'm so confused. Well, you see this 0.47771? That is log 3. And you see this 0.6989? That is log 5. So essentially, there it is. And that plus, so essentially that plus is this plus, see? So that exponent is this log here. Do you guys see that? Isn't that kind of cool? So this kind, I know this is not a direct proof. There's like a much tougher proof. So in conjunction, so let's see, if I put log 15, so let's see, log 15, let's see what that is. So log 15, enter. Okay, so it's this number. So when I push log 3 plus log 5, look at this, I'm putting plus log 5. That better be the same as this one right here, digit per digit. It better not be any different. And look at that, voila. Isn't that cool? See, it's the same thing. Log 3 times 5. Are you not entertained? Like, is this kind of making sense, guys, or no? So remember, all I'm trying to say is that logs are literally just exponents. Like, the properties follow. So, Chop, what are you trying to tell us? So on the next page, you see there's a whole bunch of blank stuff in the top. I'm going to write the properties. Here's what we're trying to tell us. And if you want a proof of these, let me know, and we can do a whole lesson on just proving. This is not a form of proof. This is just showing you that it works. So properties. So what are the properties? So we got the product rule. Product rule for logs. So what does that mean? So if I have log AB, that's the same thing as log A plus log B. We have the quotient rule for logs. Quotients. As long as you don't, because you can't divide by 0. So as long as it's not a 0. Log of A over B. So take a guess. If a product is plus, what do you think a quotient is? Minus. Log A minus log B. We got the power rule. The power rule for log A to the power B. That is equivalent to B log A. And let's see, log to exponent, and we'll make arrows go both ways. Log to exponent and vice versa. So quotient, colon, and I'm going to write, let's see what I'm going to write. Log base B of A. So there's my log, and now let me go put an arrow, and let me make it to an exponent. So I got to equal it something. Log base B of A equals C, and then here's my arrow. So B to the power C equals A. See, here's the base to the power of C equals A. You want to put those little arrows. See, B to the power C equals A. So there it is. That's how you can go back and forth from log to exponent and exponent to log. Some more side notes. Let's see. A log without a base, if no, and I put notes in quotes because it always has a base. If no base is 10. You guys remember that? So if you don't see a base, and a log has to always have an argument. Always. There's always something. It's log of something. What else? There is something called the change of base. Do I talk about it in here? Let me see. Yeah, I do. So I'm not going to talk about it yet. We should know that logs and natural logs are brothers and sisters. It just changes. ln of e is a 1. Log of 1 is 0 of any base. So those are some side notes. Okay. How do we feel? Do we feel okay? Nothing crazy, right? Okay. Now let's do some problems. So we'll go slow. We'll go real slow, guys. So let's see what it says here. Logarithm of any base. Log base b of x equals y if and only if b to the power y equals x. That's just this rule right here that we just talked about. That's that. Where b is positive, b cannot equal 1, and x is greater than 0. So those are my restrictions. All right. Verbally, log base b of x equals y means that y is an exponent of b that gives x as the answer. And there it is. All right. We're going to go slow. It says write log base 5 of c equals a in exponential form. So this is all I want. So I'm looking at this first. I'm just looking at this line right here. That's all you're doing. So here's my base. So I'm going to write 5 to the power of A equals C. Done. There it is. Exponent form. Nothing crazy, right, guys? Okay. Example 2. Write z to the power of 4 equals am in logarithmic form. All right, I'm going to zoom out so I can look at my little, how they're related. Like, oh, okay, well, this says, let's see, 5, so this z must be the base, so I'm going to write log base z of m must equal 4. And then you can test it just to make sure. Let's see, z to the power 4 equals m. Z to the power 4 equals m. Yep, check mark. It works. We're good. And that's it. That's all I wanted. And did we know this, the relationship between logs and exponents? Or no, just until now? Or okay. And there it is. Okay. Oh, remember, guys, if you guys need a formal definition or formal proofs, let me know, and we can take care of it. All right. Back in the day, this used to be, I guess, complicated, quote unquote. I guess it goes even further back, like log rules. Now you can just type this into your calculator. So if I wanted a decimal approximation of this, I would just go, okay, take your calculator and click on math and look for something called log base. So scroll down until you see log base. There it is, letter A, and you push enter. And you push 5 here, and then you push 17 here. And then that's it. There's my answer, 1.76037. 1.76037, and it keeps going. There is something called the change of base property, guys, that you can always do. And we could always call this, let's say you have a scientific calculator and you can't put like a different base. You can call this, you can go log of 17 divided by log of 5. And that will also give you 1.76037. Look, I'm going to put my little fraction thing. And I'm going to go log 17 divided by log 5. Bam, look at that. Shav, I don't like logs. I like natural logs. Okay, no big deal. ln of 17 divided by ln of 5 will also give you that number. So look, I'm going to do the alpha y equals, enter, ln of 17, ln of 5. Bam. Isn't that kind of cool? I know, you guys are probably like, okay, that's enough. Let's just use this stuff already. All right, let's use it. Remember that we got the change of base, so you can always change the base of your logarithm. How do we use it? By the way, this is not the only way to do it, guys. There are so many different ways. I actually prefer Desmos. If you have Desmos and it's multiple choice, I think it's probably easier just to type that out, this in Desmos in the first column or first row, type that in Desmos second row and see where they intersect, and that's your answer. But let's say you don't have Desmos, but you have a scientific calculator, then this is how you do it. It does say using logarithms. So I have 7 to the power 3x equals 983. Now, sometimes you can kind of guess what it is, especially if it's like a perfect, something like a perfect exponent, like, I don't know, x squared equals 81, then you know that x is 9, or 9 to the power x equals 81, so then you know x is 2, some stuff like that. All right, you guys ready? I want to solve for x. So what you're going to do is you're going to use the power rule, this one right here, to bring the x down. So what do? I come over here and I write the word log, and I put this on the inside. Whatever you do to one, you do to the other. So there it is. Now I'm using my power rule, so I'm going to write use power rule. Now this rule comes from somewhere, guys. It just didn't come in. If you want a proof, let me know, and we can do probably the next activity. We can do a proof on that. So here it is. 3x log of 7 equals log 983. All right, next. What I want to do next is I want to get rid of the 3 log 7. So this is all a product, 3 times x times log 7. So I'm going to go and I'm going to divide. Divide by 3 log 7 divided by 3 log 7. And here's my answer. If you want to leave it in terms of logs, you can go x equals log 983 divided by 3 log 7. If you want to write fancier, you can write 1/3. Let's do it with the change of base formula. Log of base 7 of 983. You could also write it as 1/3, or okay, I was gonna say I already started. Ln of 983 divided by ln of 7, and all this equals, I don't know. Let's see what it is. So I'm gonna go for my enter, and I'm just gonna type in. Where am I gonna type in? Log 983 divided by 3 log 7. Log 983 divided by 3 log 7. So there it is. It's that answer. And by the way, if I use my, let's see, 1/3, I'm just letting you guys know. You can see like all these different answers, guys. Math, and then I go to log base, and look, it's going to be the same. Log base 7 of 983. OMG, it's the same thing, digit for digit. Isn't that cool? 1.18035. 1.18035. How are we feeling, guys? Okay, let's go to the next one. All right. Remember, guys, this is not a lesson. This is just an overview. So this is not a full-blown lesson. Hopefully these are getting easier for you guys. I have log base 2. I have log base 2. I have an expression. I have an expression. And I have that equaling to 3. I know. We're all tired. There's a plus symbol in the middle. So that means I can combine these two into one log. Log base 2, big parenthesis, little parenthesis, x minus 1, close, open, x minus 3, close, close, equals 3. Are we okay with that? Okay, remember what we're trying to do. We're trying to solve for x. So what I'm going to do now is I'm going to get rid of the log by turning this into an exponential. Turn into exponential. So here we go. Base 2 to the power 3 equals that on the inside. So here we go, guys. 2 to the power 3 equals x minus 1, x minus 3. Are we still okay? So far, I don't need a calculator. So far, so good. 2 to the third power. 2 times 2 is 4. 4 times 2 is 8. And then I'm just going to expand this really quick. X times x, x squared. I have a negative 1. I have a negative 3. So I'm going to have negative x minus 3x. So that's going to be minus 4x. Negative 1 times negative 3 plus 3. Are we still okay, guys? Okay. Next, you want to zero this out. So I'm going to go minus 8, minus 8. Chop, why do you want a 0? Because you can solve for stuff that equals 0 pretty easily. It's when it equals stuff that it's hard to solve. So x squared minus 4x, and the difference between 8 and 3 is 5. The 8's larger, so minus 5. Are we still okay? See, you can see where your algebra skills come in, guys. This is where you guys took all algebra 1. 0 equals 2 numbers that give you negative 5, but add up to negative 4. 5 and 1. X minus 5. X plus 1. There it is. So I have two answers. From this, what will give me a 0? Well, if x is 5, 5 minus 5 is 0. 0 times anything is 0. Or if x is negative 1. That makes sense? Okay, now you got to check it. Check. Remember that, I guess I'll write it here on the side note. Y equals log x. Remember that x has to always be greater than 0. Child, why is that? Because, see? So I'm looking at this expression here. So x has to be larger than 1, and x has to be larger than 3. So this is my restriction. So I need to be larger than 1. So which one can it not be? It can't be the negative 1. So this one will be false. So the answer is this one. So let's see if this is true. Log base 2. And if I plug in a 5, 5 minus 1 is 4. Plus log base 2. 5 minus 3 is 2. Let's see what that equals. Well, remember what this means, guys. This means 2 raised to what power is 4? Well, 2 raised to what power is 4? 2. And then this means, this one here means 2 raised to what power is 2? What power is that? What number is that? 1. What's 2 plus 1? It works. Chav, I want to use the calculator. Fine, you could have used the calculator. You could have gone, let's see, math with the letter A. Math, letter A, base 2, 5 minus, I already forgot it. 5 minus 1 plus math, alpha A, log base 2 of, and I want to type everything digitally or just exactly the same. 5 minus 3. You could have done this, and then look, you would have gotten it. If you tried the other one, you're going to get an error. You want to try the other one? Okay, let's try the other one. -1. So let's just change the 5 to a -1. So I come over here, push enter. I'm going to go all the way to the left, and I'm going to put -1. So second insert -1, and then delete that. And then I'm going to go to this one, and I'm going to go second insert -1, delete, and push enter, and voila. Okay. Now, Yanni, that's a demerit. I know, everyone's tired. All right. Some more of this. Guys, I've seen this question so many times on entrance exams. Like, okay, not that I've seen entrance exams, on practice entrance exams. This one is very popular. Something very similar to this. Maybe it's not an E. Maybe they changed the base to a different base. But if you can do it for that one, then you can do it for all of them. Oh, look, we only got 2 left. All right. Do you recognize this? Does that look like something? Let me see. Let me rewrite it. You see how there's a 2 there? So I'm going to rewrite it. E to the x, close it squared, minus 3e to the x plus 2 equals 0. Doesn't that look very similar? Very similar to x squared minus 3x plus 2 equals 0. And didn't you solve those for algebra like all the time? Well, let's see. How do I do that, Chop? X minus 2, x minus 1 equals 0. And then, look, there it is. Those are my factors. And, x minus 2, x minus 1, -2 times -1 is positive 2. -2 minus 1 is -3. And the only way it's going to equal 0 is if x equals 2 or if x equals 1. 2 minus 2 is 0. 0 times anything is 0. 1 minus 1 is 0. 0 times anything is 0. So because it's so similar to that in blue, you can rewrite this, guys, but you got to recognize it. You look at it and like, oh, okay, yeah, I see it. This is like an x. So I can rewrite this as e to the x minus 2, e to the x minus 1 equals 0. See? And then you just get something like, okay, well, the only way this will be 0 is if e to the x equals 2. That one's possible. And how else can I get it? If e to the x equals 1. Okay, so hopefully one of them is automatic to you, that you don't need a calculator. This one right here, there's only one answer for that one on the right-hand side. E to the x equals 1. What's the only x value that will give me a 1? Yeah, just 0. Anything raised to the 0, well, almost anything. 0 raised to the 0 is indeterminate. But besides that one, any number besides 0 raised to the 0 will always be 1. Yeah, 0 to the 0 is indeterminate. That's, you'll get to those when we get to calculus, when we start doing cal. But right now we're not there yet. How do you guys feel? All right, look at this one. Chav, how do I solve for x on that? Well, let's use the logarithmic property, the power rule. We're using this one. We're using our power rule. We're using this one right here. It doesn't have to be logs, guys. You can use ln. I'm going to use ln because of e. So I'm going to come back and I'm going to write ln of this. Whatever you do to one side, you do to the other. So now you have this. Here's what you have. You move that x to the front. X ln of e equals ln of 2. Side note, remember that ln of e is equal to 1. So x equals ln of 2, and that's my perfect answer. You can leave it alone like that, or you can just type it into the calculator. You can go ln of 2. Oh, man, clear. ln of 2. And voila, there it is, 0.6931. 0.6931. There you go. How are we feeling, guys? What's up?
Hi, John. Do you have like 3 rubber bands?
I don't have any rubber bands. Sorry, miss.
Cool.
All right. Are we feeling okay, guys? We got one left. I think we might have to use Pythagorean theorem on this one. Pythagorean theorem. Quadratic formula. We'll see right now. I don't remember. Okay, we'll see what's up. That's about. Solve the logarithmic equation ln of x plus 3 plus ln of x plus 5. All right, guys, there's a plus right in the middle. So I'm going to write ln, giant parenthesis. I'm going to group these together. X plus 3, close, open. X plus 5, close, close, equals 0. Are we still okay? All right. Next, I'm going to turn this. You guys probably like logs better, so let me go ahead and put it on the side. Side notes. Log base e of x equals ln of x. So knowing that, that's just from the change of base properties. I'm going to turn this into log. Log base e of x plus 3, x plus 5 equals 0. Are we still okay? All right, here we go. Get rid of it, turn it into an exponential. I guess we could have done this from the beginning as well. Like some of you are probably saying, Chop, you could have just done e to the caret. And then that would e and ln cancel each other out because they're inverses of each other. Yeah, that's fine. Here we go. E to the 0 equals x plus 3, x plus 5. Anything raised to the 0 is a 1. So that's 1. X times x, x squared, plus 3x plus 5x, 5, 6, 7, 8, 8x, plus 5 times 3, 15. I'm going to subtract 1, minus 1, minus 1. 0 equals x squared plus 8x plus 14. Is there any two numbers that multiply to give you 14 that add up to 8, 7, 8, 9? Nope. Not that I know of. I mean, there is, but at the high school level, like integers or fractions or rationals. Nope. All right, so we're going to have to use the quadratic formula, guys. Remember, 0 equals ax squared plus bx plus c. And we can get x by doing negative b plus or minus square root b squared minus 4ac all over 2a. That comes out a lot more often than you think. You've probably seen it in physics. You're probably going to bump into it in accounting. That formula is known as the quadratic formula. Cool. I know there's other ways. You can probably type that into Desmos and see where it crosses the x-axis. But right now, let's utilize this. So my a is 1, my b is 8, and your c is 14. So here we go, guys. X equals negative 8 plus minus square root 8 squared minus 4 times 1 times 14. All this over 2 times 1. So all that over 2. So I'm going to do the positive one first, and then I'm going to do the negative one. So I'm going to have two answers. Take your calculator. I see you guys writing. So take your calculator. I'm going to push alpha y equals enter so I can have a little fraction here. I'm going to go negative 8. So you guys help me out. Negative 8. And I'm going to go plus, and I'm going to go square root. And it was 8 squared minus 4 times 1 times, what was my c? 14. All over 2, right? 2 times 1. So there it is. I'm going to store that to a. Store alpha a. Put it in a. And then I'm going to go back. And instead of a plus, I'm going to put a minus. Just hover over the plus, put a minus. And push enter, and I'm going to store that to b. Does everyone see what we did? So negative 2.5857. So let me write that down. Negative 2.5857 and negative 5.4142. Negative 5.4142. All right. Knowing my domain restrictions, I come over here and I see, okay, remember, let me write y equals ln. Remember that y equals the ln of x, that x must be greater than 0. So I look at this one here, so that means that x must be greater than negative 3. I look at that one here, x must be greater than negative 5. So I'm looking at the most restrictive one, which is, actually it's the negative 3 one in this case. So I have to be bigger than negative 3. So if I have to be bigger than negative 3, which one can I not be? Yeah, it can't be that one. So it has to be this one. But let's test it. Remember, I stored this in A, and I stored this in B. So all I'm going to do is I'm just going to plug in an A in here in my calculator, see, and see if I get 0. So let's see. Ln, and I know we're almost done, guys. Alpha A, was it -1? I already forgot. -3, +3. Ln A plus 3, close. Was it plus? Ln, what was the other one? So A plus 5. Ln A plus 5. And let's see. Push enter. Yep, I get a 0. Let's try the B. It's gonna give me an error because I can't be. You can't be that number. B and B. See? Okay. How do we feel, guys? Do we feel a little better? All right. We have a handout activity. Don't worry. Eventually, we'll have delta, but for now, we have a handout. And yeah, that's it. That's all we're doing. So let me stop this.